For a start, this question requires us to find f0, f prime 0, f prime prime 0, and f prime 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 0. Anyway, if you have to look at this question, what it is trying to lead us to do is to execute the entire Maclaurin series expansion process. And when it comes to Maclaurins, like what we have discussed in our outline again, and some of the questions that we have done within Achievers Online, what I always encourage students to do, is to do a bit of exploration. If you think manipulating the equation will allow you to, carry out the process of differentiation easier, please go ahead and do that, because we can always apply the process of implicit differentiation to differentiate whatever equation that we derive at. For example, what I have here, if I were to let y be equal to I'm going to let y be equal to this 1 plus 2 sine x, I can actually change this to e to the power of y. It is equal to 1 plus 2 sine x. It is going to be an expression that I think it will be so much easier to differentiate. So let's give it a try starting from here. If I were to differentiate this with respect to x, on the left hand side, it is going to be e to the power of y of dy dx. And this will be 2 cosine of x. This is, I think, the max I can go. I'm going to just stop here. Now I'm going to go for another round of differentiation to find d squared y over dx squared. So on this left hand side, I'm going to execute a product rule. So it is going to be e to the power of y of d squared y over dx squared plus e to the power of y of dy dx, because I differentiate e to the power y, and this term dy dx. This is minus 2 sine of x. So what I have here is e to the power of y, d squared y over dx squared, is plus e to the power of y of dy dx squared is minus 2 sine of x. This is going to provide for me f0 later on, and this is going to be f prime 0, f prime prime 0. I need to differentiate it one more time in order for me to get an equation involving d cubed y over dx cubed, which is going to provide for us f prime 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 0. So let's differentiate this one more time. This, if I were to differentiate e to the power of y, d cubed y over dx cubed. This is going to give us the f prime 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 0 later on. Plus, differentiating e to the power of y is e to the power of y of dy dx. Then rewriting this again, d squared y over dx squared. Differentiating this, it will be e to the power of y of dy dx. Then multiply by dy dx squared. Then I'm going to differentiate this, which is e to the power of y of 2 of dy dx, then to the power of 1, and differentiating using chain rule, this is going to be equal to minus 2 of cosine x. This and this, I can actually combine them together. So what I have is e to the power of y, d cubed y over dx cubed, plus 3 times, because this and this, 1 plus 2, 3 times of e to the power of y, dy dx, d squared y over dx squared, plus this is e to the power of y, dy dx of dy dx squared. This is minus 2 cosine of x. So with this few equations that I have, I'm going to find f0, f prime 0, f prime prime 0, f prime 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 0, by substituting x as 0. So when x is equal to 0, I'm going to try to find f0, which is going to be ln of 1 plus 2 sine of 0. Sine of 0 is 0, so this is going to be ln 1, and ln 1 is 0. Next, I'm going to make use of this to find f prime 0. So substituting x as 0. When x is equal to 0, in fact y is equal to 0. So it is going to be e to the power of 0 dy dx is equal to 2 cosine of 0. Cosine 0 is 1. So this tells me that dy dx, okay, is going to be equal to 2 multiplied by 1 divided by e to the power of 0 is 1, this is 2, and this is going to give me a f prime 0. Okay, next I want to find f prime 0 by making use of this. It is e to the power of 0 d square y over dx square plus e to the power of 0 of dy dx is equal to 2, so 2 to the power of 2 is equal to minus 2 sine of 0. Sine of 0 is 0. Okay, this tells me that d square y over dx square, okay, this is going to be equal to minus 2 times 0. This, if I were to bring over to the other side, it is going to be minus 1 times 2 square divided by e to the power of 0 is 1. And this that we have here, this is going to be equal to minus 4, and this is our f prime 0. Wait, last this, wait, it is going to give us our f prime 0. Wait, substituting x to be equal to 0. This is e to the power of y, and y is equal to 0 when x is equal to 0, so it is e to the power of 0 d cube y over dx cube plus 3 times e to the power of y is 0, of dy dx is equal to 2, so 2, and d square y over dx square is minus 4, so here is minus 4 plus e to the power of 0, and dy dx, which is 2, dy dx square, so it is going to be 2 to the power of 2. Okay, in fact, this we could have combined them together, okay, to be dy dx to the power of 3. Okay, but you know what I mean? Okay, so anyway, this is 2 to the power of 3. This is equal to minus 2 cosine of 0, which is 1. Okay, so what I have here, d cube y over dx cube, okay, it is going to be equal to minus 2 times 1. Okay, then minus away 3 times 1 of 2 of minus 4, minus away 1 of 2 to the power of 3. And this divided by e to the power of 0 is 1. I will be able to evaluate this to be 14. This is f prime 0. Okay, we have gotten this, and hence we are supposed to write down the first 3 non-zero terms of the Maclaurin's expansion for fx. Okay, so fx, using the Maclaurin's expansion formula that is in the formula sheet, this is going to be equal to, okay, we want the first 3 non-zero term. Okay, the first term is actually already 0. So anyway, it is going to be 0 plus 2 of x plus minus 4 divided by 2 factorial of x squared plus 14 over 3 factorial of x to the power of 3 and so on. Okay, these are the first 3 non-zero terms of the Maclaurin's. So it is going to be equal to, this is 2x minus 2x to the power of 2 plus 7 over 3x to the power of 3 and so on.